Hi, everyone. Welcome to the latest edition of Walter's World, the podcast series from Astadia. Astadia is a global service provider, and we focus on mainframe migrations and modernization. And this podcast series is really designed to bring in some of the industry leaders in this space to help talk about topics that might be of interest to people who are considering alternatives to their mainframe. And today I am delighted to have with me Larry Mead, who's the principal program manager for Global Azure, Azure Global Engineering. Larry, thanks so much and welcome to the podcast series.
Well, thank you, Walter. This excited to be here, and hopefully we'll give some good information for the listeners.
I think it's going to be great for people to listen to your experiences and recognize, the types of customers that you've worked with and the things that you've seen as you worked over these last many years in mainframe alternatives. So, Larry, can you tell us a little bit about, exactly what do you and your team do for Microsoft?
Well, we're part of a group that's called the Critical Infrastructure Team within Azure Global. And what that essentially means is that we look at how to best host applications that would be considered critical infrastructure, into Azure. And certainly anything that's coming off a mainframe is probably critical infrastructure for the customers who are using that application. So our job is to make Azure the best place to host applications from a mainframe for customers who are looking for alternatives. And also, very important, is working with partners like Astadia to have their solutions work, and perform in an optimal manner within Azure. So those are our main focuses, but we also work directly with customers, when needed, especially the larger ones or the ones that have maybe some things that aren't common, as far as migrations are concerned, and transformation is probably a better word to use. And then once we've done that, then we have a blueprint for, other customers if we move forward. So that's essentially what our team does.
And that certainly makes sense. You mentioned the larger customers, and Larry, I know I've enjoyed working over the years with you on some really large joint customer opportunities. I think the audience might be interested in your opinion, what are the 2 or 3 most important elements for an organization to consider when they're looking at mainframe transformation alternatives?
Well, that's a very good question. And I would say the first thing they should look at is, what do they really need when they want to land in a different platform like a cloud platform? By that, I mean, what do they need for availability? What do they need for throughput? What are their SLAs? What is their DR requirements? What are the things that I'll call almost the non-functional requirements that they're going to have for these applications? I mean, the mainframes have always been pretty solid for delivering those. So we have to take a look at what is it that, that are, they, do not want to have any compromise on as they're going into a platform like Azure. So that would be the first thing. The second thing would be, okay, am I happy with the applications that I have? Just because I'm considering moving off the mainframe doesn't mean that the application is not doing what I want it to do. If I'm happy with that application and I'm still maintaining it, then that's a different kind of a transformation into the cloud than let's say an application that is not maybe meeting the business needs of the customer. Under those conditions, I might want to consider what the cloud can do for me in moving this across to maybe either enhance that application or perhaps even replacing parts of it as part of that transformation. So that's the second thing. And then the third thing that is very important is, how do I get from here to there? Because, if especially with the larger customers, that's not something that's done over a weekend. That's something that can take several months. It could even take a year or more to do, especially for the ones like you and I have done that go up to like 300,000 MIBs. That's a very large customer, by the way. Not everyone's that big, but anything that I would say is over, say, 10 to 20,000 MIPS, even as when we get into looking at, I need to have a plan for how I get from here to there, and do it in a way that does not disrupt my business in that process. And my end customers are either, exceeding their expectations, or at the very minimum, at least meeting those. So if you take care of those three things, at least you're on a good path to, do that transformation.
I think you are spot on as always with that, Larry. For me, it's there are no two mainframes that are exactly alike, nor are there no two landing zones that are going to be 100% the same for customers. And understanding that roadmap and how you're going to get there, defining that on the front end is critically important. If we can, let's talk for a second about PaaS services. How do you see customers implementing PaaS services as part of their transformation program?
Okay, that's a very interesting topic, because first off, you can do VMs with some of the transformation, and there's value that you can gain from VMs. But a lot of customers will say, okay, if I do that, what's happening as far as if I'm doing it on a VM, they see a VM as needing a person, right?
Mm-hmm.
So if I'm implementing with PaaS services, I can probably now do things with out another FTE to run my stuff in the cloud. So that's the first thing. The second thing is PaaS services, by their nature, tend to be the more elastic type services. There's the ones that can allow me to scale more seamlessly. That's true with our data services like SQL DB, our Azure SQL DB in Azure, or it's true with our Kubernetes service, AKS. So this also brings in a more seamless type of scalability. Now, you can still scale with VMs. I'm not saying you can't, but that's a little bit more where I'm turning them on and off in order to resize them. Now, I can have where I can have elastic pools too, but it's more straightforward if you're doing it with the PaaS services. And then the last thing that I would say, some of the things that's being added is really where a lot of the innovation is going within the cloud. So if you're looking to take advantage of some of the innovation that's happening in the cloud, you're doing things like microservices and you're containerizing everything and things like that. Probably one of the best ways to take advantage of that is to use proven technologies for that type of service, and usually the PaaS services are there. So those are the things that we really see customers taking advantage of. So not only are they having maybe fewer FTEs needed to once they get it into Azure, they're also getting some features that they did not have in the mainframe, especially in the ability to more seamlessly scale up and down.
That makes sense. So you just raised a couple of interesting topics. I've got a couple of questions I'd like to follow up with on that, specifically about using different technologies. From your opinion, what are some of the technical advantages then that organizations might see? Or is that what you're really talking about, being able to kind of do things differently where you leverage things like microservices? Are there any others you can think of?
Well, there's two main ones, the ability to more seamlessly scale. And then the second one would be to take advantage of things like microservices, where you would be able to then sort of change your way you build applications, make them more agile, be able to implement different technologies. And Azure, fortunately, embraces that. So, and doesn't necessarily embrace it in a way that's uniquely Microsoft. So let's say I wanted to do something with OpenShift. Well, I could do that on Azure too. OpenShift's available in our marketplace. And by the way, technologies that Astadia worked with can take advantage of OpenShift. So, I mean, all those things are available. So there's that. Plus, the other one, I can rethink how I'm actually, say, deploying some of my services within the cloud. And I'll give you a really good example of that. Let's say I'm doing, people say they want to get around, batch. They want everything to be more real time and event driven or something of that nature. Well, I think event driven is great, but some events, kind of trigger off batch. And and I really don't see a way around that when you have things like close of market for financial systems and things like that. There, unless the business changes, which the cloud is not going to just change the business overnight, although it changes it to some degree, but it's not going to change things like you have market open and market close. So I guess the point is that if I have something that's event driven, I don't have to think in the term of a batch run the way I did it with my traditional COBOL systems. If I'm implementing things with some of my PaaS services, I could say, hey, you know what? I'm going to talk financial systems here. I'm going to take every account that I either have in this core banking system or this investment system that I'm running, and I'm going to, let's say, apply dividends to it, or if it's investment, or I'm going to apply service fees or distribute interest to it. If I'm doing that towards all the accounts in it, I could use something like Spark maybe to do that in a much more efficient way of using that compute, to the point where it might be advantageous to actually do an export to something that Spark can run, like in a NoSQL system like Cosmos DB, or even into the Parquet, which is like a data lake type system. Then I could run something like Databricks, which is the PaaS service for Spark that Azure has, to do that. And what we found is the time savings, especially for the large customers, we can cut several hours off their end of day processing because of the parallelism that can be done, as opposed to having to do something, bring it all together, sort it, then distribute it all back out, and then finally reload it. You could maybe take that all and put that into a single step with Spark. So that's what I'm talking about from a point of view of rethinking when you're taking advantage of the things that are available for you on the cloud.
That's perfect. And you just segued it perfectly into the second question I wanted to ask as a follow-up. And that's about how customers, what experiences you're seeing where customers are actually extending the life and value of their legacy application once they move to Azure, being able to use these new technologies. Do you find that more people just say, I'm going to get to Azure and save some money? Or are people really starting to understand these technologies that you just mentioned and starting to be able to re-envision the way that they have these applications in place and what can be done with them?
Well, it kind of is a little bit of both. I don't want to say it's just one or the other, but typically the initial thought is saving money. I'll be very straightforward. The initial thought is, okay, I could probably save money, but if I'm not getting value out of the effort and I'm introducing risk without getting value, is that really something that I want to undertake? Because I had one time a Department of Defense customer say to me, okay, so what if you can save me $20 million a year? I'm not going to put $1 billion asset at risk to save 20 million a year. So you have to look at but they finally did it. And they did it because they were getting more value out of making that change. If it just came over as is, it wasn't worth the risk to them. But if they were getting more value out of the system, then it was worth the risk, because they were actually getting something that they were unable to do on the prior system. So I would say that, that is something that is not just all money. Money was the initial thought there, but we were being shut down because it wasn't worth the risk. But when they looked at the value they could get out of it by doing some of these transformations that would allow them to take advantage of other things that are in the cloud, all of a sudden that became something that they wanted to do. So I would say that, we still see the customers that are strictly money is the thing that they're after. You still do see that, and they can get a significant savings by getting off the mainframe. But more and more customers are looking at, okay, I've got this core IP that's in this, especially if they've developed the systems themselves. I've got core IP. Do I really have to rewrite that to maintain it? Do I have to replace that? By the way, replacing it is not as simple as it sounds, because these applications could be 20, 30, 40 years old. And what does that mean? They've done a lot of customizations, along the way. And there's probably not something that they can get from a vendor that has all of their customizations. So the ideal case would be that you can save the IP that's critical to your business, that is giving you some kind of differentiation, but also be able to take advantage of other systems as they are available. And usually going to the cloud, you can do one or two things when you get there. Going to the cloud, I always recommend, if you're moving an application, really consider moving that data too. Don't leave the data on the mainframe. There's other reasons than just innovation for that. But let's say that you've made that decision. Once that data is over on the cloud, you have a lot of options. But the second is the application. Okay, when I have the application, off the mainframe, I can now interact with it more readily with other systems. So for instance, a lot of the technologies allow interfaces into either Java applications or .NET applications pretty easily. And, I was already talking about using a Spark application that was using Scala, which is kind of like Spark's version of Java, to run some of those things. So you just get a lot of different possibilities that come up. And, as you mentioned, all customers are unique to some degree when they get to be, especially the big ones. So what we have to do is find, what is real value that we can do for them, as part of making this migration. And that brings up a good point that, Microsoft, it's not just about moving, with my team, we work very closely with our account teams that are also very enterprise focused. And quite often they already have some other things that are moving into Azure. Perhaps they've got some kind of data systems with SQL Server, or even Oracle for that matter, that they're moving into Azure. And they have some systems that are already set up in an infrastructure in place. Well, what we say is, if the applications are being moved into that, let's take and incorporate the mainframe into your mainstream way of moving forward, sort of your data center of the future. That also extends the life of the mainframe application. Now it's part of the mainstream of what that customer is taking forward. So I would say that's the other big thing is, don't think of the mainframe as applications living in isolation when they're brought to the cloud. Think of them as being, integral part of everything else that the customer is doing within the cloud.
We have seen the same thing where people truly start to see the benefit of not having two distinct environments and two distinct systems, but looking for those points where you can benefit by letting them talk to each other and letting them share data, letting them share access to logic. So I totally agree with you about that.
Okay, well, great.
Larry, from your perspective, how do you feel that people should really think about addressing concerns for performance, both compute and IO, and security when they're going through transformations?
Well, all of them need to be addressed. Now, quite frankly, I think compute's the easiest one to address. I mean, customers quite often may think, well, this mainframe's this big, powerful box. Well, it is, but if you look at the power that's in the cloud, and really that'd be any cloud vendor, but we'll just concentrate on Azure. We've got more equivalent of MIPS, and we don't call them MIPS. What we call them Azure Compute Units, by the way. So we've got our own thing for MIPS now. But anyway, my point is we actually have magnitude of more power that's actually in the cloud that you have access to. And that could either be scaling up. So we've run, there's something called the ZREF benchmark you might be familiar with, but we've run that with a lot of our partners where we can easily scale up to just for a single LPAR of 25 to 30,000 MIPS. Now, my experience is that very, very few customers, even the 300,000 MIPS customers, have a single LPAR that's using more than 25 or 30,000 MIPS. So, even if you need to scale up, you have that, compute capability with in Azure. But even better is taking advantage of being able to scale out. That's where, if we can containerize this, if we can deploy it in AKS, then we can, one of the customers we worked with, we took them from 65,000 MIPS to a solution that was running in, our Azure Kubernetes service, AKS. where we had 20 nodes of 4 vCPUs each, and that was doing what the online was doing with in that 65,000 MIPS mainframe that they had. And then we then used Cosmos DB as the data side, and we were easily able to meet the compute there. And but that does bring up the next piece, which is, what do we do with the data? I actually think that that's really more of the thing that we spend time upon, because one thing mainframes do really well is move data around. They may not be doing all the fanciest compute in the world. They're not. I don't think of a mainframe as an HPC, high performance compute system, but some people did that with like Fortran way back in the day,
Right.
like me. But these days, if you're doing things with R and stuff like that, you're probably, or you've got it over into, you're doing computational fluid dynamics or something like that, you're probably doing scale out for that type of compute. But the key to being able to have the mainframe do that IO is making sure that we got both the IOPS and the throughput that you need for it, because mainframes are very fast for that. Plus, a mainframe has 2 other features that are kind of nice. You've got that sort of IO channel that you've got where they can use something called hypersockets to have very, very low latency for doing that IO. We've worked with customers who, even if it's where the where we don't have high latency with the IO, if it's moved into Azure. One customer had 10,000 round trips to the database for a single transaction.
Wow.
Well, yeah. So even if that only takes 1 millisecond, I just added 10 milliseconds to my transaction, right? So under those conditions, you need to be in the microsecond range, right? So we had to get it down to more like the 30 to 50 microseconds. Now you can do that. What you need to be very conscious of is the proximity of the solutions when you need that kind of performance, as well as the overall throughput. Now Azure has something called proximity pinning that allows you to then take like the storage and then have that within, we call them stamps. That's like the things where the actual physical hardware is, such that you can move that back and forth very quickly. And then also, if you really, really need to have a low latency, we can introduce things like HPC technology. We do have VMs that run in Azure that can take advantage of things like InfiniBand. And InfiniBand, can use something called RDMA, remote direct memory access, which that essentially bypasses the TCP stack. That's how you shave from, say, like 1 millisecond down into microseconds. So not every customer needs that, but if you do, we can architect it in a manner where you definitely can have that. And then the last topic is, particularly of interest these days with all the things out there like solar wind and all this, all that kind of thing that happened recently, is making sure your systems are adequately protected. And that's where security is not just about making sure that we've got the authorization being done, the authentication and authorization being done. It's also about locking things down, or hardening things is probably a better word to say, because if everything's locked, you probably can't do anything. But anyway, making sure that it's hardened in a manner. So, what I do is I always ask my customers to, consider, always consider that, any system is going to have intrusions. You just have to develop it that way. That has to be the mindset of how it's deployed. And if you take that mindset, even if you do have some kind of intrusion in your system, then you're able to do it. And the other thing is, if you do require, for instance, federal government, we do have special versions of Azure which isolate, even more. There's even one that's called air gapped. Essentially, what that means is it's connected to nothing. So, so that is probably the most secure for the the highest amount of security. But there's also there's secret and top secret, and then there's regular Azure also. And what we do is we go through the with commercial Azure, we take and we have gone through what they call the provisional authority to operate, PATO, for systems such that we can meet some of the standards. There's standards for sort of low, medium, and high for security, and even commercial Azure can meet the high. Again, it's a PATO because it's always provisional, because you have to then prove your specific implementation of it meets the requirements. But as long as you do that other part that I was mentioning, making sure that it's hardened as part of doing that, then you can have a pretty secure environment. So, like I say, it's a little bit of a journey. You have to think about it from that perspective. Mainframes were sort of fortunate in that they were a little bit more isolated. But one of the things you want to take advantage with in the cloud is the fact you're not as isolated. Well, if you're doing that, then you have to make sure that you have it hardened such that you are still having the same that same degree of security. So, as more specifically, most of my customers who are in financial services, for instance, let's see if I'm doing access to a financial services system that has, personal identifiable data, PII data. There's really 3 steps that are gone through with that as a minimum. This is even before we get into extra hardening. Is number 1, having that authentication and authorization done properly. But the second thing is I'm going to authorize, also, and authenticate also the devices that they're coming from. It's not just the people, it's the devices. So I'm going to expect a certificate from those devices. And if you don't have a certificate that I recognize, then I'm going to refuse that connection, before you even get to say who you are, right? So, so you're going to have certificates and set up so that you can have TLS, transport layer security, set up even before I do anything else. And then the last thing is that this is where we could work with the end-to-end encryption of the systems. So if my stuff is end-to-end encrypted, even if I have people who are getting access to it, they're not going to do much with it. They're going to see a lot of encrypted data, but it has to be end to end. I don't know if you remember a few years ago, one of the big box stores had an issue with some of their systems. Well, without going into it too much, the issue was the end device. It was actually the end device in the store that was, the unsecure.
It was the weak link.
Yeah, it was the weak link. It wasn't the main systems. So that just shows the importance of going end to end with all these things. And there's one other thing that I will say is that a number of the customers, we work with technologies that we have and that are also available through third parties that will, obfuscate the actual PII data. So what you're seeing has gone through a transformation, by the time it even gets off of where it's stored in an encrypted manner. So that's kind of a long-winded answer, but those are the different steps that we take to make sure that we have the type of security that you need. In Microsoft, we call that security in depth because, it's not just any particular thing that we're depending on as the only way that you can get in. It's every piece along the way has to be hardened such that, if you're not authorized to do it, it's a mindset. Way back when we used to keep the bad people out, we would program things to keep the bad people out. The mindset now is only let the good people in. That's a completely different way of looking.
Paradigm. Yep.
Yeah,
absolutely.
It's a completely different way of looking at things. So that's what we do to make that happen.
Makes sense. Larry, a question that I always find intriguing, I would really like to know your viewpoint. Do you feel that there are mainframe technologies that just really don't fit in the cloud? Are there people who are doing something so unique that the cloud might not be an option for them?
Well, there's 2 types that don't fit really well in the cloud. One of them would be I have no source code for it. Okay, and And that does happen, and I don't have a solution. There are some vendors that can take load modules across, but they have to have the underlying systems that support those load modules in order for that to happen. For instance, if the load module use CICS, they have to have something that would implement CICS calls. So if you've got systems that are using a third-party system, that is not directly like what you can get from IBM, like IMS or CICS, and you don't have source, those are really difficult
Those
to
are
move.
tough.
Yeah, those are tough. Now, if you're looking at things that maybe you don't want to move, one of the ones that I've seen people not move is if they've got something that they've got a lot of integration with third parties already with. And one of them would be like encryption. I have a number of customers who have, there's specific hardware you can get for mainframe that does, the encryption chips and devices that you can have. Some customers have that already in place, and it's just, it makes more sense just to use that as sort of the gateway into their system, and they just leave the mainframe there for that one reason. And then they move all the applications, because you still need to have sort of that's in essence their encrypted firewall, if you will, to get into their application. So, I see those as difficult to move. And then the last one is, remember I talked about what's the value of moving some of these systems. There are some systems that I'm not going to get a whole lot of value, from moving them in, and is it really worth the risk to move that? And in particular, we have some systems that I've run into with governments where, without getting into details that I can't share, it just doesn't make sense to disturb those things, and so we'll just keep them and let them be sunset, as opposed to trying to move them. So
Yeah, that
those are
whole
the
risk reward, right?
Yeah, it's a whole risk reward. So now if you're going into other things, which it's more of a, the difficulty. If I've got something that was written entirely in assembler, okay, there aren't a lot of good solutions. There's some solutions, but it may or may not be good for moving that assembler, because it's extremely efficient. And even the systems that work, if you're going to move it across, there's some vendors who have them, they're not going to be as performant as the assembler
Right.
on the mainframe. So maybe those you might want to rethink if that's a good thing to do. And then the last one, my favorite, is ZTPF. If you've got ZTPF systems, you might want to think about, how am I going to re-architect those, as opposed to how am I going to move the applications more or less as is. Now, that's all primarily assembler based too, but it could also be in C or C++. So those are probably the ones that I've hit that, we have to really think, what's the best way to do it? And maybe we're not going to move the applications just the way they are across. We're going to have to do something in the process for being able to do it, to run in the environment when you bring it. So those are probably the main ones that I can think of off the top of my head.
Okay, perfect. I would add the ones that I encounter that are always a little challenging. If someone has 30 or 40 years ago written their own version of CICS or IMSDC, or they've created their own database architecture, those are some unique challenges. Not to say they can't be moved, but they're ones that always kind of make us scratch our head when we run into them about the best way to handle it.
Yeah, I had a customer who had a VSC application that they wrote. They sort of wrote their own hosting for VSC for their customers. And in the process of doing that, they have a really nice VSC multi-tenant system. But it's just like you said, the effort to do that, is really, really hard.
Absolutely. So Larry, any parting words of wisdom for people who are listening in who are interested in exploring their cloud journey from the mainframe?
Well, I think that I'm going to go back to what do you want to do when you land on Azure, because a lot of customers have issues beyond just the fact that they want to get rid of the mainframe. Maybe they've got applications where it's hard to replace the programmers, like if they're in COBOL or something of that nature. And they look like they really do want to refactor those applications. Maybe they would like to change the languages as moving forward. So we're actually seeing a lot of that. It's not just moving things over as is. It used to be like maybe 80% moving the COBOL, for instance, as is. Now we're seeing it more like 60-40, maybe 60% still the COBOL, but another 40% that want to refactor it as part of moving it, because again, that's where they get the value. And from my understanding, there's some news Astadia has about being able to sort of expand capabilities in that manner.
Yeah, so we're really excited. Thank you for mentioning that. With our recent acquisition of Anubex, our goal at Astadia is to recognize that, as we talked about before, no two environments are the same, no two pain points are the same. So we want to provide solutions no matter what people are looking to do. And by acquiring Anubex, we now have the ability to help refactor COBOL and CICS applications, IDMS applications, natural database to the cloud, utilizing different languages. So we can go from assembler to a different language. We can take COBOL and go to C# or Java, and it just expands the portfolio. And as you know, from having worked with so many organizations as potential clients over the years, it's important to have that flexibility. So yeah, really exciting times for us here right now.
And I'd just add, I've worked with Anubex in the past, and we've always found them to be a good partner for what I would call the refactor type of technologies and moving across, to cloud systems.
Absolutely. Well, Larry, it looks like we've come to the end of our time. I really want to thank you for taking the time for sharing your thought leadership and experiences. I know that this will probably raise many more questions as people kind of digest everything that you've shared. And I hope that, as they come up with these questions, that they would, want to reach out to you to be able to kind of learn more about what Azure can do for them.
Okay, no, happy. Actually, I've got a really simple email. It's Larry Mead, LARRYME at Microsoft.com. So if anyone has any questions, follow up, be happy to have them reach out and try to answer them as best as possible. And it's been my pleasure to have this discussion with you, Walter.
Larry, it's always a treat to get a chance to talk with you. I sure do appreciate it. And for everybody in the audience, again, thank you for taking your time out of your busy day to join us. Please visit us at www.astadia.com to check in for upcoming podcast shows that we have planned. We have quite a few planned for heading through the summer, and I hope you will join us for them. Thank you all and have a great rest of your day.